Hello, dear aspirants. This is Dr. Sourav sir's class. We are now solving our National Boards of Higher Mathematics PhD paper from 2014. So, the question is about linear algebra. So, the question says us that let X be a column vector. That means X belongs to Rn, be a non-zero vector such that we have to define now a equals to x transpose. Okay, so they told us that a is equals to x transpose belongs to our m and r. That means now our a, as our x is a column vector and our x transpose is a row vector, so that this is my n cross 1 and this is my 1 cross n. So this is my A is my n cross n vector, a n cross n matrix with the entries are real. Okay, so we can easily see that the any row of the matrix, we if we leave the row 1, let our row 1 be, okay, let us take a column vector that is our x1 x2 dot 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 xn. Okay, then our transpose will be x1 x2 dot 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 xn. Then we can easily see that every row is a linear combination of this all x1 x2 dot 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 something. Every row is linear combination of this, so we can, by the elementary row operations, we can make the all rows 0 except the first row, that is our generator row. So our rank of A will be 1 because this row is the linearly independent one and every other rows will be 0 with the help of row row reduction from our Gaussian elimination theorem. Okay, now what will be? So B is telling that what is the necessary and sufficient condition for I minus 2A to be an orthogonal matrix. Okay. So let our A be a orthogonal matrix. That means A be orthogonal. That means our what can I say? Eigenvalues of A will be what? Will be an R of unit modulus. This is known to all, I think. So I let our eigenvalues be lambda, then our mod lambda is less than 1. Less than equals to 1. Sorry, am I doing something wrong? Yeah, mod lambda will be equal to 1. Yeah, then it's correct. So now we know that our eigenvalues of x and x transpose are what? Are my 0 0 dot 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 n minus 1 times 0, and what will be left? And our x transpose. Then as done in the problem, okay, then our eigenvalues of B, then our eigenvalues of B will be what? Will be R my 1 1 dot 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 1 n minus 1 times, as they say that our B is I minus 2A, so the zeros will be 1. Yeah, as our let me write it again, as my b is equals to I minus 2a. Yeah, so the another eigenvalue will be what? That will be and 1 minus 2x x transpose. Okay, so the modulus of each eigenvalue of a is 1, we know that. So our mod of 2x this thing will equals to 1. Then two cases will arise. Our case 1 is 1 minus 2x x transpose will be equal to 1, and the another case we will get, let me write it, or then it will be this. So it is minus 1. Then what will we get? So our 2x x transpose will be equals to 0. So our x transpose will be equals to 0. Now in that case, what will be the possible value? So it is my minus 1. So that 1 will also go there. So it will be 2. So my x transpose will be equals to 1. Yeah. As above mentioned that our when our x transpose is equals to 0, so our x will be 0, but this is not the case. So this thing will be the only answer of this question. So our x transpose is equals to 1 is the necessary and sufficient condition for I minus 2a to be an orthogonal matrix. Yeah, yeah. I'm telling another thing that okay, our eigenvalues are of unit modulus, we know that. So we used mod of 1 minus 2 x transpose equals to 0, equals to 1. Then we got two cases and we got two results, that our x transpose is equals to 0 and x transpose is equals to 1. Now when we get x transpose is equals to 0, the only case possible for this is our x is equals to 0. Now when our x will be 0, then the yeah then our a will be null matrix, so that cannot be possible. So our x transpose will be 1 is the only answer for the question. So this is x transpose is equals to 1 is the required necessary and sufficient condition for I minus 2a to be an orthogonal matrix. Okay, hope you are studying well, and thank you guys. Hope you understood.